Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, we are going to run this newly released Google model Gemma 3 with Llama.cpp. If you don't know what Llama.cpp is or what exactly is this Gemma 3 model, please watch my channel for these videos, both for Gemma 3 and this Llama.cpp, as I have covered both of them in great detail in very simple language. For the purpose of this video, I am going to download and install llama.cpp from scratch on my system. We will also download this Gemma 3 model from scratch in quantized format, and I will show you how you can do the inference with it. Now, the library which I'm going to use for this, as I said, is llama.cpp. In very short, llama.cpp enables you to do LLM inference with as minimal setup as possible, and you can run various models with it. It's a plain C++ implementation without any dependencies, and it uses this ggml format. If you don't know what this ggml format is, this is a GitHub repo of ggml format which you can check through it. Now, I'm not going to go into the further detail of ggml, except that ggml is simple tensor library for machine learning to enable LLMs, and also gives you high performance on commodity hardware CPU or GPU. So first, let's download and install this llama.cpp. In order to get it installed, go to its GitHub repo. From there, on the right hand side, you see this is the release page. Just click on this release page, and then you will see this is the latest release which was just done 10 hours ago. If you scroll down a little, you will see that it is available for a lot of operating systems. Now the operating system which I have right now is this, which is Ubuntu 22.04, and I have x86 architecture. And this VM, by the way, is being sponsored by our good friends at Mass Compute. And if you're looking to rent a GPU or VM on very affordable prices, you can find the link to their website with a discount coupon of 50% on range of GPUs in the video's description. So going back here, you see in this release page, I have this Ubuntu x64. So I'm just going to right click on it and save link as. I'm just going to maybe take it to my local directory. Maybe I will just create a new directory here. So I'm just calling this directory LCP. I'm going to save it there. It's a very lightweight one. You see it's already even downloaded. So if I go back to my terminal, and then if I go to that directory which I have just created, if I do ls, you will see that there is our llama.cpp. So if you have this unzip command installed, simply unzip this. So for me, it just comes preloaded with this Ubuntu system, so I didn't have to even install it. And you can also run it on Windows or Mac or wherever you are running it. This is as simple as it gets. So once you have it, then if you do ls, you will see there is a build directory. So go into that build directory, then go into that bin directory, and then if you do ls, there are a lot of binaries available, and that is the beauty of it. Now I will come to this binary in a bit, but before that, let's do one thing. Let's also download the model in the ggml format which I just mentioned earlier. Now in order to download the model, let's do this. Let me go back. Maybe I will create a new directory, which is, I'll call it my models, something like that, doesn't matter. And then in this directory, I'm going to download the model. Now where do you get the model? Just go to Hugging Face. In the Hugging Face, you see there is this ggml.org repo. From there, you will see there is Gemma 3.1. So just click on whatever Gemma model you need. So I'm just going to go with the Vision model. So you see this is a Gemma 3.4 billion. So once you click on it, this is a Gemma 3. So let's go with 12 billion. So 12 billion, and then from there, just click on Files. Once you click on Files, you will see there are a lot of quants available. So if you have a low GPU VRAM, just go with a lower quant, like first one, 7.3 gig. But I'm just going to go with this, maybe Q8, which is 12.5 gig. So for that, I'm going to right click on this, downward arrow, save link as, and then I'll just go to that my models directory and save it there. So it is being downloaded, as you can see. While it gets downloaded, let me also introduce you to the sponsors of the video, who are Camel AI. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents, with applications in data generation, task automation, and world simulation. And I will drop the link to their website in video's description. Okay, so let's wait for this to get downloaded and then we will proceed further. And the model is downloaded. Now, because we want to do the vision tasks with it, we also need one more file, which you can see is this mmproj file, which is only 854 meg. So let's also download it, and I'm also going to put it in the same directory where I have put in my language model. Now, what exactly is this mmproj file? I will tell you very shortly. So first, let me take you to my terminal, and then from here I am just going back to where we have installed Llama.cpp. And from here, in order to run these models, all you need to do is to run this command. So what exactly is this command? So you see what I'm doing here, I am just calling this CLI, which is Llama Gemma 3 CLI. That's right. So Llama.cpp comes packaged with Gemma 3 support from day one, which is really good. So I'm calling the Llama Gemma 3, which it recognizes Llama models. And then first up with -m switch, I am specifying my language model, which is 12 billion in Q8 quantized level. And then if you see, I am also giving it this --mmm proj file, which is the mmproj model file. So what exactly is this file? So this is the mmproj option is used to specify a multimodal projection file, or mmproj file, which is needed when using a multimodal or vision language model in llama.cpp or elsewhere. So this file, which is mmproj file, contains parameters required to map or project image embeddings into the text space expected by a multimodal model. And that is why we have it, because we also want to do vision task. If you just want to do the text task, you don't even have to specify it. So let's run this, and you can see that I have given it the full path to my model. So it is loading the model, it is just telling you all the configuration and all the parameters. There you go. So model is initialized and running in the chat mode now in llama.cpp. Now you can chat with your images. For example, for first, let's specify an image from my local system. So this is the image which I'm going to use, bear. And so I have given it the full path, which with this /image, it is going to encode the image. There you go. So it is encoding it. Let's wait for then code to get done. And by the way, if you are wondering if it is using CPU or GPU, I believe it is using CPU, as you can see here. And let's also verify. So this is my VRAM. So let's run it. There you go. See, no VRAM is being consumed. So all running on CPU. So let's wait for it. So the image encoding decoding is done. Just took over a minute, and then you can chat with it. Maybe you can say, okay, let's analyze the image, and then it is going to do the inference on CPU. So it is analyzing the image, and you can see that it's all running CPU. I'll just let it run for a bit so that you could also check out the speed. So this is the image which it is analyzing. So I'll just display it here too. So it says overall impression. It is going with the subject. That image prominently features a large brown bear, likely a grizzly bear, which is right. So, and if you're interested in checking out the inference of text images with this 12 billion parameter model in full, instead of quantization or 1 billion or 4 billion or whatever, you can just check out my channel. As I showed you earlier, I have covered all of them locally, and we have tested it out on OCR on various images. So please do check it out. But you can see that how easy it is to run this Gemma 3 model in 12 billion on your CPU locally, privately, offline. You don't have to even have a GPU. That's good it is. Bit slow, of course, but yeah, you have to make some trade-off one way or another. So look, I will let it run, but that's it. Let me know what do you think. These are the models I was talking about, including even fine-tuning. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.